Imagine the Mojave Desert south of Las Vegas, the sun beating down relentlessly, not a drop of water in sight. On a small bush full of tiny pink and white flowers, you see a well-camouflaged caterpillar. You watch for a moment as an ant approaches it, worried the ant may attack, but no, the ant is guarding it. Right in the middle of our desert, you have just witnessed one of the world's most fascinating relationships, a mutualism between caterpillars and ants. This important mutually beneficial relationship has been studied throughout the world for over 100 years. So how does it work? Some caterpillars have developed specialized ant organs that allow them to both attract and reward ants for tending to them. The most important of these organs is the dorsal nectar organ, which produces droplets of nutrient-rich secretions called nectar right on the caterpillar's back where the ants can easily eat it. In return for this reward, ants protect caterpillars from predators and parasites. Until recently, it was widely believed that the dorsal nectar organ was responsible for maintaining this relationship. However, work by Masaru Hojo and colleagues in 2014 showed that ants will still tend partner caterpillars even if their dorsal nectar organ has been rendered incapable of delivering a reward. It turns out ants are reacting not to the nectar, but to communication signals on the bodies of the caterpillars. The compounds used to create these signals can be classified as either simple or complex. Hojo and colleagues found that partner caterpillars that have more complex compounds that closely mimic those of ants are better communicators with the ants, making them more likely to be tended than non-partners with their simple compounds. This led the authors to hypothesize that communication via these complex compounds is what's driving this relationship, and that by simply analyzing these compounds for complexity, we can determine whether this relationship is present and how strong it is. My research aims to test this hypothesis. In local species, I want to see if partner caterpillars do in fact have more complex compounds. In this graph of my raw data, you can see, represented by each black dot, potential communication compounds found across ants and different groups of caterpillars. By identifying compounds that are seen across groups, we can identify good candidates for communication. This research has great implications for conservation. By understanding how communication works in this friendship, we can better begin to protect it, and in turn, some of the rare butterflies that we are lucky to have right here in the Mojave. Thank you.